Hello, everyone, and welcome back to Bioinformatics Bootcamp. My name is Henry, and today we're going to be going through the last part of Module 2, getting through Numpy, and then we're going to get into Module 3. We're also going to go through the first 6 challenge questions that you had to do for homework from Module 2. So with that being said, let's go ahead and jump in. So to get the code for today, you're going to need to go to our website. That's bigbioinformatics.org. Go ahead and navigate here to Intro to Biomedical ML. You can find the workshop repository link right here. And really what you're going to want to do is come over here and just download this as a zip drive. All right. Open that up, extract it. And now you've got all of the code for the workshop repository, along with any PowerPoints and the syllabus. So let's go ahead and start with the last part of Module 2. Before we do that, I'm going to go over the answers to the homework. So let me actually really quickly shut down these notebooks here. Apparently, I had a couple already running. All right, so what you're going to want to do is start up Jupyter Notebook. You can do that by coming over here, opening this up, and just starting Jupyter Notebook right there. Okay, so go ahead and navigate to wherever you downloaded the workshop code to. So for me, that's my downloads folder. And that's going to be right here. And I'm going to open up the Module 2 challenge problems. Okay, so some of these were a little bit easier than others, but some of them were really quite difficult. I asked you to do the first 6 for homework because those are relevant to what we actually got to during the Module 2 lecture. Okay, so the first one here asked you to modify this code so that it no longer produces a type error. If you see here, produces a type error. Can anyone put in the chat what their solution to this was? What did their code look like once they finished this? Okay, all right, so we got a few here. So the one that I did, and I'm just gonna include that since that's the most popular one here, is just to put str age. That was the main one that I saw people using here, like that. And you can see that does fix it. And the reason is because it converts age from a numeric to a string. And so now you can concatenate it to the other strings here. Okay. Any questions on this one? Any alternative answers that people wanted to put forward? Okay. So Adam included a return, and that would work. This is the difference between, returning a string and actually just printing a string. So return is typically more common in a lot of functions. So return is fine here as well. It's really just what did you want to use the function for? Because as we know, when you don't include the return, you don't actually have the output will just be a none. So it might print something, but it's not actually returning any value. In this case, it's actually returning a value. So either way is fine. All right, let's move on then. If nobody's got questions on this one, let's move on then to number 2. Okay, anyone want to put their answer for this one? Okay. Return list instead of function instead of, so it asks you to return the 3 largest and 2 smallest values in the list. So Okay, got a few here. Okay, great, great. Okay. Yeah, so my answer was closer to lead juice than the other ones. There were lots of ways to do this. Probably the simplest one may have been, I don't know why I put well, I guess I was trying to give you a little bit of a hint here as to like how I thought the simplest answer would look like, because it would start with sort. So you take that list, you sort it, and so that's going to go from low to high, right? So now you can do to get that 3 largest and 2 smallest, you could simply do, so it's got to return something. Okay, so first of all, it's going to return something. So you could take that list and go, 3 largest would be -3 onward. So this is going to be the last 3 in the list. As we recall, this is for accessing the data in a list. This is signifying the last third, and then this is to the end. So this is everything from the last 3 to the end. And then everything from the beginning to the first. So as we recall, in lists, you've got 0 notation. So this is actually element 3. Okay, this is the 3rd element, but this is going to be everything up to the 3rd element. So it's going to be the first 2. Okay, so now that we've sorted it, so let's just show this here. I just want to really briefly show this so that you can see here. We take our list here, if we print it, just so you can see why this is going to work, what I just did. So we've got my list. It's in no particular order, but if we do print my list dot sort, you can see here, oh, right, that doesn't actually return anything. I got caught up on my own thing here. All right, so now it's going from low to high, so lowest value to the highest value. And so if we take here the last 3, slice the last 3 here, slice the last 3 here, that's going to be the 3 largest. And if we slice the first 2, that's going to be the 2 smallest. So to get the 3 largest and 2 smallest, we just add these together, and there you have it. That's all you got to do. So does anybody have any questions on how this is working? A few people had 2-line solutions, which was great. I just like this solution because it's kind of, it's easier to maintain code that's less complicated. So using this slice notation like this is in my mind slightly nicer than actually saying the individual elements. Okay. All right, great. Well, then I'm going to go ahead on to the next one. Can anyone tell me what value of A would make this return hello world? Okay. Any other guesses? Okay, everyone's saying 20. All right, it was 20. Does anyone want to explain why it's 20? It was a little bit of a trick question. Maybe not enough of a trick question, but it was a little bit of a trick question. Well, okay, so the reason is okay. This condition is else. Right. Well, yeah, because the last one is else. Well, okay, so the trick was basically that you had to remember that a range is not inclusive, doesn't include 20. So it's everything from 0 to 20, but it doesn't include 20. Therefore, this part of the elif will not be triggered if you give a equal to 20. Okay, so we set a, run this, set a equal to 20, and it prints hello world. The reason is because, again, if you put 19 in here, it's going to say a between 0 and 20, right? If you put 21, says a greater than 20. Only 20 will produce hello world. And that's because if it's greater than 20, this triggers. And then if it's not, if it's between 0 and 20, then this triggers. If it's less than 0, this triggers. Now, this would trigger if the range included 20, but it doesn't, because ranges go up to a number but don't include that number. So just a little bit of remembering how ranges work. All right, very good. All right, now it starts to get really difficult. So given the radius of a circle, write a function, analyze circle, which returns the circumference and area in a dictionary. Was anyone able to get this one? Anyone want to put their answer for this one? Okay. Okay, great, great. Great. Were there any other ways people solve this? Did anyone do this without importing pi? It was a little bit of a, you had to kind of know how to Google that to get pi. Okay. Very good. All right. So I'm gonna go ahead and show you how I did. Those are all right. I think, yeah. All right. So we say define, analyze circle. So that's how we start our function definition. And then we could say, we'll keep it nice and simple. Which returns the circumference and area given the radius of a circle. So we'll say radius r, and we'll have that return a dictionary, okay, which contains the circumference. And as we know, the circumference is pi, but we actually don't have pi yet. So let's go back to that in a second. But let's say you did know pi and you had it stored in a variable time called pi. You can say pi r times 2. I think that's right. It's been a while since I did geometry. And then area of a circle is pi times r squared. Okay, so how do you get pi? There was, people said a few ways of doing it. So one way, if you Googled how to find pi in Python, you would have found, a lot of people on like Stack Overflow and stuff telling you, you can get the value of pi, okay, maybe this wasn't a good one. Let's see here. I guess there's an even simpler one here probably somewhere. Okay, well, oh, here it is. You could have just done this import math.pi. So that would have been one way. So you could have done, import math. And then this could have been math.pi. But I personally prefer the other way of doing this, which is from math import pi. Because I just find that to be a little bit more lightweight, personally. I prefer that way of doing things. So basically, this is going to take the value pi from the math module, and it's going to use it in this function. You could also said, because if we do this, and I'll just show you here, if we do this, and then you print pi, you can see it's actually not very precise. So if you wanted a more high precision version of pi, you could have come up here and said pi to 100 digits. And you could have just taken this and copied and pasted it into your notebook, for example. So you could have done that. But this is probably the most straightforward and simplest way to do it. All right, so let's actually run this now. So if we run analyze circle on a unit circle, we can see that it gives us an area of pi, which, as people who've taken geometry probably recognize, is the area of a unit circle. So unit circle being a circle where the radius is 1, and the circumference being twice pi. All right, so that was much more of a challenge this time. But yeah, very good job to everyone who was able to get that. All right, any questions on this one? Okay. Now it's getting really difficult. So I asked you to, and I'll just go ahead and run this so you can see this here. I asked you to take all the words from Pride and Prejudice, which was included with this notebook. And you can see all these words here. So this is all the words in the book. And figure out how many times the word the appears. So did anyone come up with a solution to that? Go ahead and put it in the chat if you've got a solution to that. Okay, Mert, that's a really interesting answer, actually. I didn't know that you could do that. Very cool. Very cool. That's actually, no, that makes a lot of sense though, doesn't it? Yeah, so I'm going to show you the way I solved this, a simpler way to solve it, and then the way Mert solved it, which was actually pretty cool. Okay, so a few different ways here are some versions of a for loop. So let's say that we're going to do a for loop here. How many times does the word the appear? So let's say you want to loop over all these words. So let's say I have this variable and I'll initialize it, count the. Let's say it's equal to 0. So for a word in words, print word, right? So just, let's say I'm testing this for loop here. So you can see I've got all these words here. I'm looping through all the words and I'm printing them as I go along. But instead of that, let's say, instead of printing it, I say if word is the, so if it's equal to the, then count the is equal to count the plus 1. So basically we're saying if we encounter a word that is equal to the, then we take our count the variable and add 1 to it. And so that's basically how you could very simply count the. And that's how we get 4,216. Okay. Now there was actually a simpler answer to this, which was more Pythonic, because lists actually have a built-in method called count. So you could have actually done, instead of all this, you could have done words dot count the. So you wouldn't have known that unless you did a little bit of Googling, but just so you know, there was a simpler way to do this. And in fact, interestingly enough, Mert had a kind of a cool solution, which I actually really like. It's a little bit confusing. I'm not sure I would actually want people to use this typically in your day-to-day coding, because it could get a little bit hairy. But basically, his solution is this. It's to actually, instead of splitting the text using spaces, which is the default delimiter here, you could split it using just the word the. And so basically what that means is that you're taking all of your text and you're breaking it up every time you encounter the word the. And this is actually in some ways superior, because our method here is not catching instances where you have the comma or the period or something like that, right? And so Mert's method would actually be able to do that. So you see, he finds more thes by doing this. However, this also does suffer from instances like thesaurus and there. And so, for example, yeah, it would catch there, for example. Yeah. So if you wanted to really do this proper, you'd probably need to use something called regular expressions, but that's really outside the scope of this workshop. But if you've got any interest in regular expressions, just Google regular expressions Python, and you'll have a pretty good time finding all that. All right, so now that we've got this done, let's go ahead now to the final problem, which was quite difficult. Construct a word count dictionary for all the words in the novel following the format: results, term 1 count, term 2 count. All right, so go ahead, put in the chat what your answer to this one was if you were able to solve this. This one was quite difficult. All right. Okay, great, great. All right. Any other answers? There were multiple correct ways to solve this. I mean, just like all these, there's multiple correct ways to solve them. Yeah, it was a really tough problem. This was really not, this was meant to really challenge you, and just attempting it is an accomplishment, I think. Okay. All right. So these are all great. I'm going to show you what my answer to this was, because I think it was slightly simpler than some of these, but it's very similar to what Anmol put, actually. So let's say that you construct a dictionary, and we call this dictionary word count. Well, I guess we called it results here, didn't we? Results, and we initialize an empty dictionary here. So dictionaries have keys and they have values, right? So what we could do is like this. We could say for word in word, okay, so Mert had, okay, so we'll come back to Mert, your answer, because that's actually a very, very good point. So let's start with the simplest possible way to approach this. So for word in words, we could say if word, if not word in results dot keys. So recall that you can get the keys from a dictionary using dot keys. In fact, I think there was an even simpler way to do this, because I think if you just said if not word in result, that would have actually also worked. But no worries. This is the way I did it personally. Results word is 1, because this would be basically the first time you encounter this word, because it's not yet in your dictionary. Else results word equals result word plus 1. Result. I think I did something dumb here. Whoops. Oh yeah, that's right, because I still have my words from when I did this. So let me come back here and redo that for a second. There we go. That's better. Sorry, I still had the split set of words from when I tried Mert's solution for the last problem. All right, so this I found to be kind of a fast and simple approach. I don't personally care for for loops, but this was, I thought, not bad. Okay, so some issues with this approach, for example. So we get the counts of all of the words, but you can see here that we see things like commas make something a new word. And in fact, you have capitalized versions of words, you've got lowercase versions of words. There's really a lot of problems with this approach because of things like punctuation. And you can see here, you've got this colon in here, you've got bracket parentheses in here. So in theory, we really don't want those things to be included. So Mert's solution is actually one of the ways that you could go about dealing with that. And I'm just going to show you here what he did. Okay. So I'm just going to sort of include this here. So let's say that we did it like this. Basically, he went through and he replaced all this sort of random punctuation and stuff like that you might encounter, right? Okay, so Okay, so if we do this, we can see now that we've gotten rid of a lot of those random punctuations. There's actually a slightly easier way to do this, and I'm trying to remember the exact way, but I think it's called the strip method, strip Python. So I'll show you how I look up stuff like this. And basically, strip is a way of removing any spaces. Python remove punctuation from string. So if you just search that, go to Stack Overflow, there'll be something that's got like a crazy number of upvotes. And if you want to look through this, you'll be able to find all the ways to get rid of the punctuation completely. It actually appears to involve regular expressions. So I'm not going to show you here how to do this. Oh, actually, there's one that doesn't involve regular expressions right here. But for right now, I'm not going to bother implementing that because that's kind of beyond the scope of this challenge. One last way to do this was what Simon suggested, which was a dictionary comprehension, which I think went something like this. So I'm going to try to put your solution in here, Simon. Which is, oh, you said you forgot to make it unique first. So words, unique, list, set, words. So this is kind of this is a way of doing things that is very Pythonic, and I didn't talk about it last time, but basically a set is a data structure that is similar to a list, except that sets have to be unique. So every element in the set is unique. And so when you make a set out of a list, it just takes that list and it makes it unique. So it's a way of getting unique. Yeah. So basically, if we wanted to get the unique words, so we could say unique words, and then we could say for word in unique words, we're going to count up all the instances of that word in words. And so that's another way to do it. And that actually, I've already tested this earlier because I saw Simon's solution earlier. This produces the same result, but it's pretty slow. So I would not entirely recommend this one. So this is a dictionary comprehension. It's similar to a list comprehension, except you specify both the key and the values. All right, just so you can see how that's working here. Oh, Anmol, okay, thank you for adding the string punctuation. So I guess I will just really quickly show this. So let's do it the way that actually includes so from string import punctuation. And so what we're going to do here is we're going to re-implement what we just showed here. And instead of doing this big long replace, we're going to do instead we're going to do strip string dot punctuation. So word equals word dot strip punctuation. And so this should work as well. And so we can see that does in fact work. Now we're not seeing any punctuation in here. One last thing you can do is you could do lower as well. So everything is now lowercase. That also helps standardize this. And this is actually a fairly satisfactory result now. Okay, so we've got everything has been converted to lowercase and all the punctuation has been taken out. So we should be this should be pretty good now. Anyways, all different fun ways to complete this. And that's pretty much it. So these next ones will be due next time. Please go ahead and give them a shot after the lecture today. Liju, do you want to, did you want to ask your question about question 10? Go ahead. And while you're asking that, everyone, please go ahead, pull up the Module 2 notebook. All right, so how do you create a float array? We'll go through that today, actually. Yeah, because you weren't really supposed to do these last four until after today, actually, because they require you to know the NumPy stuff. So let's briefly go through the NumPy part, because I think that'll make sense after we go through this. So open up the module 2 ones. Okay. So open up module 2. We're going to go through the last part of this right now. And then I'm going to hand it over to Simon to go through module 3. All right, so going back to module 2, let's jump down here to NumPy arrays. So as we talked about last time, you can import NumPy as NP. This is just an alias for NumPy. So we go ahead and import NumPy as NP. It's a module. So we talked about that last time. You can make an array. You can instantiate one like this. This creates a one-dimensional array. This is now a NumPy array containing 1, 2, and 3. We can create 2D arrays. Right, and I made this mistake last time. So this is actually NP, not NumPy. So it's NP.array, not NumPy.array. I made a mistake last time where I said NumPy instead. So this is a 2D array. We can even make 3D arrays. We can make as many dimensional arrays as we want. We could have a 1,000,000 dimensional array if we needed to, although there's really not much point in doing that typically. So what makes this a 3D array? Well, it's got columns, it's got rows, and it's got stacks. So stacks of 2D arrays. So 2 2D arrays stacked on top of each other makes a 3D array. 2 3D arrays stacked on top of each other would make a 4D array, and so on. All right, and we make these with these nested lists. So let's start with the creation of arrays. So you really just do this with these this list notation. That's a pretty simple way to do it. So we can create a Boolean array, a 2-dimensional Boolean array, for example. We can see that is a ND array. That stands for n-dimensional array. We can also create arrays using the arrange method. So if we do a range of 10, that's going to take all the integers from 0 to 10, not including 10, and it's going to put them in a one-dimensional array. Now, arrange can, it takes the start, stop, step notation, just like slices do. So start and stop are now specified. So start was 10, stop was 20, so we go up to 19 because we don't include 20. We can also include a step. So we've got everything from 10 to 100 in steps of 5, not including 100. We can also create a float array using you can use a decimal point here to do that. That's just one way to do it. There's others. All right, so I went through that last time, so I want to just really quickly recap it. Now, ND arrays, n-dimensional arrays, have many properties to them. One of the properties I'm going to talk about is dimensions or shape. So let's talk about a 2-dimensional array. If we look at the .ndim property, that stands for number of dimensions, it says 2. It's a 2-dimensional array because it's rows by columns, 2 dimensions. Now, let's get the shape of this array. If we look at the shape, it says 2, 3. Now, the 3, the last part of this is actually a tuple. The last part of this tuple is always going to refer to the innermost brackets. Okay, so it's pretty much always referring to the columns, right? The 2 refers to the next innermost, which in this case, since it's the 2-dimensional array, is just these here, these brackets. These indicate the rows, right? So that means 2 rows, 3 columns. And that's the shape, 2 rows, 3 columns. And you can see here, this is the generalization of what I just said, because the format is always going to go outermost dimension all the way down to the innermost dimension of your data. All right, so that's very crucial to understand. Outermost dimension all the way down to innermost dimension, because everything in NumPy and in Pandas, for that matter, is going to follow this format, outermost to innermost dimension. All right. So if we make a 3D array and we look at the shape, it goes 2, 2, 3. That's because there are 2 stacks Each stack has 2 rows, and each row has 3 columns, or 3 points within it, depending on how you think about it. So 2, 2, 3, 2 stacks, 2 rows, 3 columns. All right, so going outermost dimensions signified by the outermost brackets to next outermost to innermost. All right. Any questions on that so far? That is a very crucial concept that you'll want to understand here. Okay, I'm going to go on then. So you can actually, for the okay, so if you did a 40 array, for example, it's the same thing. So let's say we make an array here that's got 4 dimensions in it. So make a 40 array. So open up some brackets, open up some more brackets, open up some more brackets, open up some more brackets. Okay, so we're talking now about like the order of our brackets. This is the outermost. This is the 4th dimension, 3rd dimension, 2nd dimension, 1st dimension. So let's say in here I've got 1, 2, 3. Okay, so this is actually a 4-dimensional array. So let's say I've got 2 of these dimensions here. Let's say 4, 5, 6. Okay, and let's say that we've got like this. All right, and let's say I've got so this is a 2 rows, each with 3 columns, and this makes up 1 stack. So let's say I've got 2 stacks, and so we've got 2 stacks here. Okay, and let's say that I've got, for some reason, so these are now stacks of stacks. So I've got 2 stacks of stacks, right? So this is our 40 array now. It's getting a little bit hairy, but hopefully you can kind of see how this works. Okay, so let's say that here we had 3 stacks of stacks. We can see that now the outermost brackets, which are these ones here, I'm going all the way back up to find this. It's the outermost brackets contain 3 stacks of stacks. So that's why 3 is here. Each of those stacks of stacks contains 2 stacks. 2. Each of those stacks contains 2 rows. 2. Each of those rows contains 3 columns, or you could say 3 elements in a list, depending on how you think about it. So 3. All right, so hopefully that makes sense. You can have infinitely many dimensions. Usually we deal with 2. All right, so arranging, we get everything from 0 to 15 here. We can reshape this 1-dimensional array 5, 3. This is 5 rows, 3 columns. And I know that because 5 is the outermost dimension, and that would be rows. 3 is the innermost dimension, which would be columns. 5 rows, 3 columns. If I wanted to make it, 1 stack, which would mean this is now 3-dimensional, I could do it like that. So nothing changed except that I now have an extra bracket here. So you can kind of see how this is working. If I made it 30, I can make this 2. And now I've got my 2 stacks here. So you can see how this is working with the dimensions. Okay. Lee Ju says, when I create a float array, I found the array has the wrong value. It's not a problem about the array of integers. We'll get to float arrays in a second. That's kind of an important point. We'll get to that in a second. You can simplify this code by just combining the arrange and reshape into 1 step. You don't need to put them on separate lines. All right, so can you create an array with all the even numbers from 2 through 13 in 2D format with 2 rows and 3 columns? All right, so go ahead and give this a shot. And once you got it, please put it in the chat. Can you please mute Emma? Thank you. Okay, so anyone able to do this one here? All right, great, great. All right, great. So, Lichu, that's absolutely right. I think actually, let me just double check this here, but I think that is correct. So this is Lichu's answer. Was np.arrange 2.14.2.reshape 2.3. And now this gives us 2D format, 2 rows, 3 columns. So we see that here, and it's all the even numbers from 2 through 13. And that's absolutely correct. Very good. All right. Any questions on that? All right. So this is crucial to understand because it's also going to determine how you access data within an ND array. So there are several ways to do that. So let's say that we have just a one-dimensional array. Simon says, oh, okay. So Simon says, note the brackets inside or the parentheses inside of reshape. That's because this is a tuple, and that is absolutely correct. So this would be how you would do that, and you want to make sure you're doing it with a tuple like this. I know we didn't talk about what those are, but essentially it's similar to a list, and you have to use them for a lot of circumstances. Don't worry about them beyond that for right now. All right, so we make a one-dimensional array, and with a one-dimensional array, to get the second element, you can treat it just like a list, and you can just access it just like a list. So we get the second element from this NumPy array just like this. Now, the way this works is just like we were doing with shape. You start from the outermost dimensions, comma, all the way to the innermost dimension here. So if we've got a 2D array, if we want the first row, second element, then we would do it like this: first row, second element, because you go outermost, so outermost dimension, and then innermost. Okay, so outermost dimension, innermost dimension. And then if you've got more than 2 dimensions, you just go increasingly inner until you reach the innermost. So you can see here, this gives us first row, second element, remembering that we're in 0 index here, right? All right, so now if we create a 3-dimensional array like this, let's say we wanted the third element in dimension 1, the third element in dimension 1, fourth element in dimension 2, and the second element in dimension 3. That's what we want to pinpoint using those coordinates like that. We could say third element in dimension 1, which is the stacks, right? So that's the stacks. Fourth element in dimension 2, which is the rows. Second element in dimension 3, which is the innermost, that's the columns. So hopefully this is kind of making sense. So we do 2, 3, 1. So that is the third stack. That is the fourth row. So that would be right here, this row. And then we will be taking the second element, which should be 66. So again, we start outermost. So this is the third stack. So outermost bracket here, outermost bracket. So that's our third stack. So this is stack 1, stack 2, stack 3. Okay, so we found stack 3. Now within stack 3, we're going to take the next dimension, which is the rows. Okay, and we're going to take the fourth row. So that would be 1, 2, 3, 4. That would be this one here. And then we're going to take the second element, which is this one here. I know this can be super confusing at first, so I wanted to just go through that in detail, but hopefully this is making sense. This is the most confusing part, but it's the most important one to understand when you're first starting out. Okay. You can also use slice notation to get elements within a dimension. Okay, so for example, if you wanted to get the second column from every row in the first stack of my_r, you would do it like this. Okay, so that is the first stack, every row, second column. First stack, we take every row within that stack and we get everything in that second column. And that's what you see right here. All right. Challenge problem, which statement, how to access every other column from the last two rows of the last stack of my_r. How would you go ahead and do that? So if you feel like you've got it, go ahead and put it in the chat. We'll give a little bit for this. This is pretty tough. Simon, I feel bad. I'm going like way over the time I thought this would take.
We'll be fine.
All right. All right. So any other answers? Okay, so this was Li Ju's answer. So if I'm just going to copy and paste this in here. All right, so what does this do? This takes the fifth stack, right? So index number 4, which is the fifth stack, which is the last one. You could have also done -1. That would have also given the same thing. So you want to have every other column from the last two rows of this. So every other column from the last two rows. So the last two rows would be 3 through 5, but you could have also done -2 like that. Produces the same thing. So I would recommend using the negative notation just because even if the number of rows change, this will still be the last two rows. And it says access every other column. This actually accesses every column. So if we wanted every other column, we could do that. Because again, this is, you have to include the step if you want every other column. And this would be the answer. Okay. All right, so I'm going to move a little bit quick here. So you can also use logicals to access data. We can use a Boolean array, for example, to access the elements of num_r, which correspond to the true in bool r. So if we say num_r brackets bool r, that will give us 3, because that is the element of num_r for which bool r was also true. Okay, so you can use this approach. It's very powerful, especially when you start dealing with two-dimensional data. So let's say we wanted to check wherever our data set here was greater than 3. We could make a Boolean array to test that. See, we now have a Boolean array, and wherever data set was greater than 3, we see it says true. So that corresponds here. If we said data set of bools using this bracket notation, it just returns the elements of data set where it was greater than 3. So you can see how this starts to become very powerful as you start doing more and more complicated operations. There's other ways you can do this that I'm not going to go through because, frankly, we don't often use them. At least I don't often use them. And I'm not going to go through this either for the sake of time. You can look at this on your own. This is also not something you typically have to use, or at least I don't typically have to use. All right. So setting elements, you can do that by using the exact same notation you use to get elements. So let's say that you want to set the second row, fifth column value to 100 in dataset. Very easy to do just like that. So you just say this part of data set equal to 100. Now, here's where you can start to combine these ideas. Let's say that we wanted to take all the values of this data set that were greater than that are greater than 3 and set them to be 0. Very easy to do by combining the idea of using a Boolean ND array to access the elements of a numerical array and then setting those values equal to something. You can also do this with the where method, but I'm not going to bother going through that since that was what we skipped above. Finally, you can also use any and all. Any and all are logical operations that take in a Boolean data set or a Boolean NumPy array, and they tell you whether a condition is met, right? So basically, they're going to take a Boolean data set and they're going to return some value depending on the values of that Boolean data set. So in this case, we're creating a Boolean data set using data set equal to 0. So just to show you what that looks like here, it's a Boolean ND array where all the values that are, oh, whoops. So got to reset that here. Where all the values where an element is equal to 0 will be true. You can see none of them are equal to 0 here, so none of them are true. So we're asking the question here, are any values of this Boolean array true? And we see that they are not. There are no values of this Boolean array which are true. Okay. If we instead set this to be 1, this now changes to true because this would now have one true element right here. All right. Now, np.all is going to try to find where, so it's basically going to ask the question, are all of the values in a Boolean array true? In this case, we're talking about the Boolean array data set not equal to 0. So let's test that here. So we see that, in fact, all these values are true. Therefore, np.all is also true because the np.all will be true when all the values of a Boolean array are true. Okay. Any questions on this section so far? I know I'm going kind of quick through this, but I wanted to make sure we get to Simon's part before too long. Well, if you do have questions which come up on this, feel free to put them in the chat at any point, and I will make sure that we stop and get to them. Okay. So let's go ahead to some mathematical methods you can do on ND arrays. So in this case, we create an ND array from with the values from 0 to 8, and we reshape it to be 3 by 3. Okay, so nice square array, 2 dimensions. We can multiply this array by a scalar. So quite easy to do that. You can also add it, addition by a vector. You can add it to a one-dimensional array. So basically, when you do addition by a vector like this, so a vector being a one-dimensional array, you can just add that one-dimensional array to every column. I think I said that correctly. Yes, yeah. I didn't take linear algebra, so this part is admittedly a little bit difficult for me. You can compute the sum of all the values in your array. You can get the mean of all the values. Okay, so if we take out this axis part, it just gives us the mean of all the values, but adding the axis in allows you to specify that you want to compute this mean on one dimension only. All right, so axis is another way of saying dimension. Axis equals 1 means we want to compute the mean along the second dimension. In our data set, where there are only 2 dimensions, the second dimension is the rows. So we're computing the mean along the rows. And we can see here that that is 1, 4, 7. Just reminding you what my data is here. So 1 is the mean of row 1, 4 is the mean of row 2, and 7 is the mean of row 3. So that's why we get 1, 4, 7. If we wanted to do it along the columns, just set it to be 0 because the columns are the 0 dimension. So the mean of column 1 is 3. The mean of column 2 is 4. The mean of column 3 is 5, I think. Yes, that is correct. I'm not very good with math, so that's why I'm not teaching the actual machine learning part of this. All right. You can also get the max of some array using axis again as an argument. So we're going to get the max along the columns. So the max values of the data set along the columns are 6, 7, and 8. Again, column 1, max value is 6. Column 2, max value is 7. Column 3, max value 8. So that's why it's here. If we set it 1 instead, that's going to be the max along the rows. So 2, 5, and 8. All right. Any questions about this? This is actually very, very crucial to understand how this axis argument is working. This is really, this is going to inform a lot of what you do from here on out. Any questions on how the axis part is working? You can compute the dot products using np dot. And you can also calculate the Pearson coefficient of two one-dimensional arrays like so. So that's just np.corg_coef. You can also pick random numbers. So NumPy has a module within it called random, or a submodule, if you will. And it's got a method called randint. So this is going to take a low and a high, and it's going to find a random integer between those values. You can also get it to return that based on as a two-dimensional array or more based off of the shape you give it using the size parameter. So we give it 5 by 3, so 5 by 3. You can also generate a random float between 0 and 1 by supplying a shape to the random.rand method. So we want a 4 by 4. Okay, 4 by 4 array with random floats between 0 and 1. That's what we get right here. Well, you're going to hear about a lot more NumPy later. So for right now, let's take questions really quickly, and then we need to go on to pandas because that's more relevant for what you're going to be doing before you get to Dan's part. So any questions on this before we go on? Hopefully, Ligia, this answers your question about how to get the floats. If anything was confusing, please do go back through the notebook and test stuff out on your own, or go back and watch the lecture video later. Sorry again for the confusion about the NumPy part. I flew a little bit too close to the sun on that one. All right, so I'm going to turn it over now to Simon for talking about pandas. Oh, actually, Simon, did you include Pandas Series in your part?
No, actually.
So I'll do the Pandas Series really quick then.
Yeah, just do through the end of your notebook, and I'll pick right up from there.
Okay, so let's do that. So if you don't already have pandas installed, you can do it with pip install pandas. So if any of you are using Anaconda, you already have pandas though. It'll give you a message like this: requirement already satisfied, pandas in whatever. You can import pandas as PD like this. So this is just like we did with NumPy. Now, pandas objects are based on NumPy arrays. So if you understand NumPy, you basically understand about 80% of how pandas is really working. The last 20% that you don't quite understand is going to be based on this idea that not only does pandas include NumPy arrays within it, but they get names. And so let's talk about the simplest kind of pandas data structure, which is called a series. A series is really just a one-dimensional NumPy array where every element has a name. You can construct one from a dictionary like so. So we've got basically 1, 1, 2, 2, 3, 3. So we've got here now, this is our Pandas series, and we've got the values 1, 2, and 3, and they have names 1, 2, and 3. Similar to a dictionary, you can access the values using their names. And because these are just one-dimensional arrays, you can also access the values using the integer indices. So if we want to access the first element, we can do it like that. So we access element 1, which is a 1. You can also use Boolean indexing just like you can with NumPy arrays. So wherever the data is equal to 3, we want to pull that out, and we get that right here. You can see it says here int 64. Don't worry about that for right now. That's really not going to be important until a little bit later on what that means. So let's turn this over to Simon now, because Simon, I know you actually do this part. So let's turn this over to Simon now. Okay, so Simon's going to now talk more about Pandas data frames and get you started with working with some basic methods with those.
All right. Let me share my screen.
This is going to be all in module 3. So if you haven't already, go ahead and pull up this notebook.
Yeah, it's the module 3, module_3. So I'll give you a couple of seconds here. You're going to have the install things here. Just execute that real quick in case anything isn't installed yet for you, and that can just do that before we get started. All right, so for the sake of time, I'm just going to get started because the beginning here is a little bit of me talking about what a Pandas data frame is, and you guys can open the notebook and install and execute that first code block while I do that. So a data frame, a Pandas data frame is a two-dimensional rectangular array. So it means it has 2 dimensions, and there's something in each cell. So in case that whole multi-dimensional axis stuff from before confused you, well, congratulations, Pandas only is 2-dimensional, so you won't have to worry about it. There's only rows and columns. So it is how a lot of data is basically easily represented. So each row is an observation, and each column is a different variable. So each row might be different people, and each column might be their age, their gender, their date of birth, right? So what makes a data frame different from a NumPy array? So as Henry mentioned, data frames are basically built around NumPy arrays, but they're much more specialized. So if we just go through these bullet points really quickly here, a data frame can contain different data types in different columns. So one column might be numbers, one column might be booleans, one column might be strings, but each column has to be homogeneous. Whereas a NumPy array is always all homogeneous. It's all booleans or it's all numbers. A data frame has names for its rows and columns, which makes inspecting data a lot more convenient from sort of a data science perspective, because your columns will have names for what's in them. And data frame also integrates well with plotting packages such as PyPlot, Plotly, or Bokeh, and Seaborn. You'll see a little example of this in this notebook as well, and then a lot more in the project we'll go over if we have time, and that you'll do in the homework. And lastly, as I mentioned before, a data frame is always 2-dimensional, whereas a NumPy array can be n-dimensional. So in conclusion, NumPy arrays are really powerful for matrix math, or basically any problem that can be expressed as an n-dimensional array mathematically, whereas a data frame is a specialized version of a 2-dimensional matrix that is completely geared toward data science. It's really easy to summarize and visualize data with it and extract information from them. So really each NumPy and Pandas arrays have a specialized function where they vastly outperform the other. NumPy is very much the math, whereas Pandas is very much the data science. So if we create a data frame by hand, we're going to do this first code block here where we import pandas as PD. So PD is just an alias for the pandas package. And then the pd.dataframe method allows you to create a data frame from a dictionary. So here data is a dictionary with three entries, column 1, column 2, column 3, and each has a range of numbers in it. And then the index argument here allows you to name the rows. The index is the rows. And then the names of the entries in your dictionary will be the column names. So if we display that, you'll see there's column 1, column 2, column 3, row 1 through 4, and you have your numbers in it. Also, if you use display instead of print in Jupyter Notebook with a data frame, it'll come out formatted nicely like this. So that's nice to remember. So we can access individual columns or list of columns by their names. And we use single brackets just like we would for any other array. And then the column will be extracted as a Pandas Series object, the object that Henry introduced just now. So you can think of this as sort of just Pandas Series stacked next to one another. Each column is a series. So if we execute this, we display MyDF column 1. It comes out looking like this. And if we look at what type it is, type of MyDF column 1, it's a Pandas core series. So it is extracted as a series. I'm going through this quite fast because we have a lot to get through. This will all be on YouTube. You can look at it as many times as you want. You can post pictures in chat. I'll be happy to hang around later and answer them, or post questions in chat, not pictures. And I'll be happy to hang around later and answer them. But I just want to give you guys the basis for the homework. So if we do the same thing, we access column 1, but this time we use double brackets. Instead of being extracted as a series, the column will be extracted as a new data frame. So if we do this, you can already see it's formatted like a data frame. And if we display the type of this double bracket notation, it'll be Pandas core data frame. So a quick challenge problem here. Can you write one line of code that will access both column 1 and column 2? So instead of just using column 1, we want both column 1 and column 2. So post in chat if you have the solution. Yep, that's correct. So display. So now we just pass it a list of columns. Boom. Column 1 and column 2 accessed as a data frame now. See, when we ask it to give us multiple columns, we do this as a list, right? So you can see here, it was also as a list. It's just a list with only one element. And that tells it that we want to get a data frame out of it. There's no way to do this where we want it as series because a series only has one dimension. So if we want multiple columns accessed, it won't necessarily be a data frame that we get out of it. All right. Yes, Adam, that works because now you've passed it 2 lists. Column 1 is your first thing here. Sorry, here. Adam says this works. Oh, or maybe not. Oh, missing that. Yeah, that works because what you've done is you've created a list with one element, column 1, and then you've created another list with one element, column 2, and you've added them. And when we print that, you've just now created a list that's column 1, column 2, which is what I had before. So that's why that also works. All right, moving on. If you want to get access to the row and column names, you just do this with mydf.index for the row names and mydf.columns for the column names. So that will give you an index element that contains row 1, row 2, 1, 3, row 4, and column 1, 2, and 3. Note that there are no open and close parentheses here because index and columns is not a method. It's not a function. It is just an attribute. so a variable that belongs to MyDF. All right, so accessing individual elements. Two ways of doing this, by index or by name. So we'll go through index first. To access an element of a data frame that's located at an index, we use the method iloc. Note that iloc takes its arguments in brackets, not in parentheses. So if we want the second row, second column, if we go up here, second row, second column, that should be 12. And correct, it is 12. You can see that I just pass it as 1, 1. We can also use double brackets, just like before, where we put put each coordinate into its own brackets. And in this case, instead of just extracting the element, it will create a new data frame containing only that element. And again, if we use type, we can see that this is in fact a data frame, whereas before type, it was an integer. We can use this method to not just access individual cells, but actually to assign them a new value also. So here we're setting the second row, second column to 0, and then displaying it, and then we're setting it back to 12 using the other notation and displaying it again. So now you can see we've set it to 0, and we've set it back to 12. So both notations work to set a value within a data frame to a new value. Now let's do the same thing, but use Pandas's feature of having named rows and columns. For this, we use loc instead of iloc. So again, the arguments are are provided in brackets, not in parentheses. And we can again just provide them the two coordinates separated with a comma. So row 2, column 2 should again be 12. And the type will be an int. Just like with iloc, if we provide each coordinate within its own brackets, it'll be extracted as a data frame containing one element. So here, it'll be the same element, and it'll be a data frame now. And we can use the same way as we did with iloc. The loc method can be used to assign new values. So again, we're setting this value here to 0, and then returning it back to 12. Are there any questions at this point? I know I'm going fast, so don't worry about asking questions. Like, it's totally fine. All right. So, quick challenge problem. Can you write a line of code that accesses all of column 2? You can use either the loc or iloc method. So instead of accessing one element in one column, like one row and column combo, all of column 2. Post in chat when you have it. Yep, that'll work. Let's try Sonaza's solution. Display my df.iloc, and now she's provided a slice that is going from start to finish all the way, and then the second column. And it will do that as a series, so that'll work. Remember that you can also do this just if you don't want to use loc or iloc. I know I made you this time, but if you don't want to do it, you can also just access it as this. All right, good job. So just like Henry explained with Numpy arrays before, you can filter rows with logical gates. Basically, in the index, where you say you want to access MyDF, and the index that you give it is a logical condition. So we want MyDF where column 1 equals 1. Sorry, equals 1. And then in the second one, we want MyDF where column 1 is strictly smaller than 4. So if we execute this, you'll see that this filters rows. So here it only, yeah, Mert, yours works too. The loc, that's exactly right. It's equivalent. So you can see here that it filters rows, right? So column 1 equals 1 is only true for the first row. So it will only display this row. Column 1 is strictly smaller than 4 is correct for the first 3 rows. So it will display those 3 rows. So that's how you filter rows based on conditions that you set on one of the variables in the data set. So this is really helpful when you're dealing, again, if you have a bunch of people in the rows and you have their first name, last name, gender, and age. You want only the people who are younger than 65. You just can set a condition age smaller than 65, and it'll filter the rows and only return the rows where that condition is true. Next, we want to discard some data. So sometimes we don't have complete data sets. Actually, most of the time we don't have complete data sets. Dan will go into this a lot more in his exploratory data analysis lecture, but I just want to introduce the concept of null values here. So in Python, null values are often represented by this NumPy object np.nan, which means not a number. So we're just going to import NumPy real quick. And so if we set, I'm actually going to split this. If we set one of the values here to np.nan, the row 1, column 1, this will be an nan now. So now for row 1, column 1, we don't have this value. So what do we want to do? There's a lot of different ways we can handle missing data, but the easiest and most sort of brute force way is to just delete it. So if we say drop NA and then display MyDF, what do we see? Row 2, 3, and 4. Row 1 has completely disappeared. Drop NA deletes all the rows where there is at least one missing value. Now, you can imagine that if you have a somewhat sparse data set, this might be a pretty brutal approach to your data set, and you might discard a lot of data that you have just because you have one missing value in that row, but it is a way that works. So drop NA, again, filters rows, and it drops anything that has at least one NA value. So quick challenge question on line 3 above. Well, it's not line 3 anymore. It's this line here. What does the argument in place equal true do? You can unmute or type in chat with your answer. What does this argument here do? Exactly, Sanas. That's the question. What do we think this argument here specifies? If anyone has a thought. I haven't explained this yet, so if you don't know, that's fine. But just if anyone has an idea of what that might do, let me know. Correct, Mert. The operation happens on the object itself. So if I just reset my DF real quick. All right. I swear I'm almost back to where I was. All right, so it's an NAN. So if I deleted this, the in place equals true argument, it returns the exact same thing as I had before. Nothing happened. This is because I didn't do anything. This function just returns the data frame with this row deleted, but it's not assigned to anything. It's just, I could do test equals mydf.drop_na. And then I display mydf, nothing's happened to it, but now my test data frame has the dropped first row, right? The in place equals true argument means that I don't have to reassign this. The in place equals true argument means that this function directly modifies my_df. My_df is now changed. So it's a very dangerous argument to use if you're not careful, because you are modifying your data frame with that operation. So again, if we delete this, and we say in place equals true, now mydf has already been modified by this line of code. Does that make sense? Okay, great. All right. So as you know, this has been filtering rows of data. What if we want to drop a column of data? What if we want to drop column 1? So if we want to discard an entire column of data, we use the drop method. So mydf.drop, we provide the labels of what we want to drop, column 1. We provide the dreaded axis argument that I'm not going to go over again right now, but trust me, this will work because I tested it. And then again, in place equals true because we want it to affect mydf directly. And then we display mydf. Now column 1 is gone. From here to here, column 1 has been dropped. All right. Moving on to two pretty straightforward but very helpful methods is count and sort values. So count will just simply count the number of non-NA values in each column. So you can see here, if we display mydf.count, so it'll give you column 2, column 3, and it'll say column 2 has 3 non-NA values in it. Column 3 also has 3 non-NA values in it. If we sort the values of mydf, we have to give it an argument that says by. So what column do we want to sort it by? Well, we say we want to sort it by column 2, and we say ascending equals false, meaning we want to sort it descending. So high to low. You can see here they're low to high. If we do this and we display what that returns, now it's high to low. We've basically reversed the order of rows here. Questions about that? There are a lot of summary methods in Pandas. So you can calculate the mean, you can calculate errors, you can calculate various things. And the Pandas documentation has all of those methods, but they all work sort of like this, like along this sort of type of syntax. So if you know how to use these two, you'll be able to learn how to use all the others with just a little bit of Googling. Okay, cool, Henry. we'll go over that at the end. All right. So merging two different data frames. Often you're going to get data from different sources. Say you have, well, as you'll see in an example I'll show you in a minute here, hopefully we'll get to it, you could have data about Super Bowl games, and you can have another data set that contains data about the ads run during various Super Bowls. So one has data about the games, how many points were scored, who won, blah, blah, blah. And the others will all have data about all the halftime ads. Okay, well, now you want to merge these two data sets because you want to do some sort of correlation between the number of touchdowns and the cost of a halftime ad or something like that. So now you have to merge two disparate data sets. How do we do this? Well, first, let's just make another data frame, right? We'll just make my_df2. So mydf is this thing we had before. It's got 3 rows and 2 columns. And mydf2 now it has 4 rows, sorry, and 3 columns. Note that both data frames have a column called column 2, but the other columns all have different names. So they have some overlap. You need to have some overlap if you want to merge them. So now I'm showing you 2 types of merges. There's more, but I'm showing you 2 types of merges. You can either have a union of the two data sets where you just bring everything together, and that's what we call an outer merge. So you're going to say mydf.merge. You give it the other data frame you want to merge it to. And on how, the kind of merge you want to do, you say outer. So it's the union of the two data sets. And then you say on. This is where you tell Pandas which column the two have in common. Like what column do you want to match? So if we execute this and we show the merge data frame, now we see it has column 2, column 3, column 4, and column 5. And you'll note the column 3 here in row 4, or in the last row here, has an NA. So you'll see it's 11, 31, 41. So that's this row right here. It got tacked onto the end. That's because the first data frame didn't have a row 1. So it had nothing to match this to. So it just created an NA value here because we wanted the union. We didn't lose any data, but we had to fill in the blanks with NAs. Similarly, if we do an inner merge, that is the intersection, where we only keep things, where we only keep rows where we have data from both data frames. So if we do this, now you can see we only have 3 rows and 4 columns. And you can see the row here with 11, 31, and 41, this guy here, row 1, it's gone. It's nowhere to be seen because it didn't exist in this data frame, and we only kept the things that exist in both data frames. So this is the intersection, whereas this here is the union. Those are, I think, 2 of the most helpful types of merges that there are. Are there any questions about this before I jump ahead to a very simple visualization example? Okay. So data visualization is a huge subfield of data science, and it's, oh, if the column names will different, all columns will appear. So you can see that, you can see that the column names are different except for one. You do need one column name that's the same. You can, there's a way you can tell it left on and right on, where you, if the column names, if the columns have different names but the same data, you can tell Pandas that, but generally the actual data needs to have some sort of overlap. Column name. Change the column name of df2. Except, yeah, so they are different, right? Except the common column. So the common column is column 2, and the others are all different. This has column 3, this has column 4 and 5. Or is that not what you mean? Okay, cool. No problem. All right, so quick data visualization. So it's a huge subfield and near infinite complexity, and we obviously don't have time to go into a lot of detail. I'm just going to show you a very, very basic example using the matplotlib.pyplot package. That is a very basic package that you'll find a lot, but it's a bit complicated if you want to get into the details of it, which is why we're not going to get into the details of it and just use a very simple use case. So we'll go over this line of code in a minute here. We'll go further into this, into the TV mini project that'll basically just kind of have you read as preparation for the homework, and then we can look at it in detail during the review class next week. Just know that matplotlib.pyplot is a very ubiquitous but complicated library, and we're not going to get into the details here. There's a link to a cheat sheet here if you want to learn a bit more. But basically, you can create a basic scatter plot with the plot method. Now, the plot method can be used on its own if we import this package as PLT, like we're going to do here. We can say plt.plot, and then we provide an x for what goes on the x-axis. So mydf2.column2, and we can provide a y, mydf2.column4, for example. And then kind, we tell it what kind of graph we want. So scatter here means a scatter plot. So that's one way to use it, standalone. We can also use it in this way, where we use it directly on the data frame object. MyDF do.plot. And again, we provide the X, the Y, and the kind. The only difference is that we provide the X and Y axis. We can just give it column names here because it'll already know which data frame we want to apply it to. It's really the only difference. So if we execute this block of code, this is our data frame. We want to plot column 2 versus column 4. And that is going to be a very unexciting line of dots. But this is how you can make a very simple graph. I changed the axis labels here. I gave it a little title. And then always remember that you need plt.show once you want the program to actually display the graph. This builds the graph. Sorry. These lines here build the graph. This is what actually shows it, actually displays it. Does anybody have questions about this right now before we do a little challenge problem, and then we're almost done? All right, so a little challenge problem. Can you change the code above? I've just replicated it here. To make it a line plot instead of a scatter plot. So instead of individual dots, we want a line here. Well, hint, the word line here is key. So if you think about what might you change in this code block here to turn it into a line plot instead of scatter. Yep, that is correct. As a matter of fact, line is the default. So even if you were to, oh, that was a mistake. So even if you were to just delete it, it would do the same. But for completeness sake, yeah, this is how. All right, the last two topics are grouping, and then we'll just do a quick t-test to show you how stats work. And then I will just show you the TV project notebook and explain to you why it exists. And then I'll send you off into the homework. And for those of you who want to stick around, we'll go over the axis argument with Henry a little bit. And I'll answer any questions you have about what it went over today and any questions you might still have about the homework from last time. So grouping data by a variable. So let's mess with our data frame a little bit. And we're modifying it so that the first two rows here in the first column are 11, and then there's an NA in column 5 here, right? So this is our data frame that we're working with. If we simply apply count, it'll do what we think it'll do. It'll tell us that we have 4 non-NA values in column 2. We have 4 non-NA values in column 4, and we only have 3 non-NA values in column 5. But what if we wanted it a little bit more granular? We actually want to group this data. We don't just want to know what's in each column. We want to know if we group it by column 2, we make groups based on the values of column 2, and then we count the other 2 columns. What would that look like? So if we first use the group by method, and we group by column 2, and then we use the count, what does that look like? Now we've created an index based on column 2, and column 2 can take the values 11, 13, or 14, right? Well, in the group where column 1 is 11, we have 2 non-null values in column 4, here, these 2. We only have 1 non-null value in column 5. There's a null, and then there's 42. In the rows where column 2 takes the value 13 or 14, these 2 here, we have 1 value each for column 4 and 5. So first we group by the variable values of column 2, and then we count the other columns. So say you have, again, your data frame with a bunch of people, and there's a column that's age range, and you only want the people who are in the age range of 25 to 35. So you group by your age range variable, and then do whatever you want to the rest of your data. This is how this can be used in data science. Note here that you can make chains with these dots. Object.method can be chained. Object.method1, .method2 is where you sequentially apply functions to your data. That's a really great question, Zanas. So let's find that out. The answer is annoying. Display my df2.groupby. It is a DataFrame GroupBy object, which is infuriating because this object is not a raw data frame. It is now a grouped data frame where behind the scenes, it's not meant to be displayed. It's meant to be used for other stuff in the future, such as count, such as mean, such as standard error, whatever. So this is a great question, Sanaz. This is, honestly, I think this should be fixed. This should be displayable, but it's not. So just be aware that when you group something, you can't just display it. You don't have to do stuff to it. It's only meant as an intermediate step in processing your data. It's not meant as a sort of a visualization tool. Yes, chaining method, yes. So if for those of you familiar with dplyr and R, if you replace these dots with the pipe operator, that's exactly how tidyverse works. All right. So very last thing here before I explain the homework and send you off. The SciPy package is powerful to perform a lot of statistical tests. We're just going to introduce a simple t-test here. SciPy, you can Google it and look at the documentation to look at more advanced tests like ANOVAs or other things, non-parametric tests. And you'll need to do that for a couple of the homework assignments. But this is basically how to use these things. So from scipy.stats, we import this function called t-test_ind. So this is just the t-test for two independent means. So if we display my df2 real quick, and then that's what that looks like here. And then we're applying the t-test function for column 2 and column 4 of my df2. So these two columns, we want to see if those means are significantly different. Spoiler alert, they are. So we're going to assume that the variances are equal, because in fact I made them to be equal. And what this function is going to spit out is two numbers. The first one is going to be the t-statistic, the student's t-statistic. And the second one is going to be the p-value. So this is how we can assign, if a function spits out two values, we can assign them to two separate variables like this. And then we're going to just print two lines. The t-statistic is t, and the p-value is string p. Well, the t-statistic is about -20 and is a 10 to the -7 p-value. So very, very statistically significantly different. So this is how you do the most simple of statistical means test on a Pandas data frame using the SciPy functions. Are there any questions about this? Any questions about anything in this? So this notebook is meant to be sort of just kind of like a raw basics of the functions, of some of the most basic functions that exist in Pandas, and for you to just be sort of a reference where there's no sort of story that we're telling. We're just giving you ways of doing things. So now, next, I'm going to show you the TD project that you can use as a reference for how to do your homework, where we expect you to actually use these methods on real data and extract actual helpful information from them. So I'll go over that in a second. Before I do that, are there any questions about what I just went over? Okay. So if we look at the TV_project notebook, which if you're in the module 3 folder, do you have DataCamp courses that recommend to go over for next week? Yeah, so the Pandas one. There's an introduction to Pandas DataCamp course that is very, very good. That does basically what I did just now, but probably better because it's DataCamp. So if you're in the module 3 folder, there's a subfolder TD project here. So this is the notebook we're talking about right now. This is actually a project taken straight off DataCamp. So thank you, DataCamp. So this looks at data for TV ratings, halftime shows, and Super Bowl games. A lot of you might remember Left Shark. So here, this is basically how what I just went over can be used on real-world data. Yeah, that's a good link from Henry. Used on real-world data. So it's all already done. So this can just be a reference for you where they import 3 different data sets. They import game data on the Super Bowls. They import TV ratings data on the Super Bowl. And they import data on halftime musicians in the Super Bowl. So if we just execute this first block of code real quick, you see that there's 3 data sets. There's the venue, city, state, attendance, winner, winning points, blah, 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 a bunch of game data for each Super Bowl. Then again, for each Super Bowl, you have networks and their various ratings. And then again, for each Super Bowl, you have the musician and the number of songs they play during the halftime. And so this notebook is just going to take you through a very simple, but I think interesting analysis of these data to give you an idea of how what I just explained in sort of the dry theory notebook can be used to extract real information from real data. So if we just look at a thing here real quick, they do some histograms. They do some nice looking graphs where they do some correlations and stuff. So if you go through this notebook, you can just see how all of these basic tools that I just showed you in the module 3 notebook can be used to do some straightforward but interesting analyses on actual real world data and how this can be used out in the wild, and why these sort of building block methods that I just gave you aren't just boring exercises, but you can actually use them to do cool stuff. Once you've gone over this and sort of seen how an analysis is built, you can hop over to the module 3 homework notebook for next week and do as much as you can of this. And there are some questions here that are fairly easy, and there are others that are very hard. So don't get discouraged. Just do as much of it as you can. Here we're going to have you look at Gapminder data, which is a data set that I think is curated by the UN or the OECD or something. That's just demographic and economic data on various countries through the years. And we're going to have you do some analyses on CO2 emissions and GDP per capita and things like that, where you're going to use a very similar sort of rationale and approach to analyzing data as what's outlined here in the TV ratings, using the tools that we went over in the lecture today. And as you see, all the code blocks are empty, so we're going to have you start really writing code from scratch. That'll be sort of scary, and it'll take you a long time to sort of come up with the very first line of code to write. At least that's what it was like for me when I was learning. But that's very normal. It's very scary to look at an empty code block and just be like, okay, how do I start to solve this problem? But just do your best, and we'll go over it all. We'll go over the TV project next week in class, and we'll answer all the questions you might have then. And I'll be happy to answer anything you have right now. And then Henry has some explanations that he wants to do. See you next week, Sanaz. Thanks for all the questions. That was really helpful. All right, this is the end of my official lecture. So this is now, the floor is now open for any and all questions you might have on Henry's lecture on Pandas, mine Henry's lecture on Numpy, mine on Pandas, last week's homework, this week's homework, the TV project, anything. And sorry for racing through this. I just wanted to make sure that you guys had all of the basic building blocks from the toolkit, and just got a quick look at the TV project, so you were not stuck in the void for the homework. All right, Henry, I think you're up.
All right, it's time for me to redeem myself.
Go for it. Dazzle us.
All right. Okay, so I made kind of a silly mistake earlier, but basically the question we had was how does the axis argument work in things like sum and mean? So when you're defining a ND array, you'll do it kind of like this. So in this one, we say 2, 3. Now we always start with the outermost dimension and then we move to the innermost dimension, right? Axis 0 is the 0th element of this tuple. So this is the 0th element or the first element. This is so this is axis 0. Axis 1 is the second element here. So that's sorry, this is confusing. The notation is kind of annoying with the 0th and first thing. But when you do your sum along axis 0, what you're basically saying is I want to take the sum this way, this way, this way, and get rid of axis 0. Okay, so let's actually see an example of that now. All right, so we'll take some new data here. Data is np.arrange, and we'll arrange. We'll do an arrange of 10 through 20, and we'll do a reshape to make that 5 by 2. All right, so data is now like that. All right. So data.sum axis is equal to 0. Now that's along the 5. Now the 5 is the row. So we're basically saying collapse the rows using the sum argument. So we're basically saying we want to take the sum along the columns, right? So I'm going to get the sum of these columns. And that's why we get 70, 75. So we're saying 10, 12, 14, 16, 18. I want to add those up because I'm saying collapse that 0 axis, which is this first index here. All right. All right. So this is what I failed to understand. This is what Dan was trying to tell me the whole time. Sorry, Dan. Now that's what's going on here. Now, if instead I do axis 1, that means I'm getting rid of these. Okay, because the first axis is this one, because it goes 0, 1. And so in this case, that happens to be summing along the rows, and you're basically collapsing these columns, because that is the 1 here, right? So this is the second element, so its index is 1, because we're in 0 notation. This is exactly how it works in 3 dimensions too. I just didn't really understand it at first. So if we make our 3-dimensional, so we'll use this one as an example. All right, so if we go to 3 dimensions now, go to 3 dimensions here, it's the exact same situation. So if I want to do, if I got a 3-dimensional array, so let's say we've got an array with, what is this, 6 times 3, 18 elements. So we'll make an array here with 18 elements. Well, starting to get a little bit messy, but that's all right. So we'll make our data np arrange, just arrange 18, and we'll do it in this exact style. So 3, 2, 3, 3, 2, 3. So we've now got our, basically we've got this exact situation, but we've got it here. Okay. So let's say we want to sum using axis is equal to 0. What does that mean? Well, that means we're going to collapse this. We're going to collapse this. We're going to collapse this. But wait, we've got 3 dimensions. So that means that we're also collapsing it this way, and we're collapsing it this way. Hopefully that kind of makes sense. Okay, I guess I could have just done it here. We're collapsing it this way, this way, this way, right? So we're collapsing that axis 0 across the whole thing. Okay. right? So we're collapsing that across the whole thing. Let's see here. So getting rid of this. This is 0. Did I do this wrong again? Gotta be kidding me. No, I had it backwards. Oh, that's okay. All right. So axis 0 is
It's the stacks.
The stacks. Yeah. I had this.
So you're going to sum all the matrices together.
Axis 0 is the stacks. Right. This is, you can see how counterintuitive this is, because the 3 is the number of stacks. 3 stacks, 2 rows, 3 columns. Axis 2. All right, so you can see how counterintuitive this is. So you're summing first, you collapse axis 0. All right, so axis 0 in this case is the stacks. That means you're collapsing like this. You're collapsing like that. All right. And that's how you get, 0 plus 6 plus 12, collapse that down into 18. 1 plus 7 plus 13, collapse that down into 21. All right. So hopefully that makes sense. If I put here, okay, so just really quick, how would I collapse the columns? Can anyone tell me how I would do that? How would I sum down the columns?
Collapsing the columns means, wait, collapsing the columns or summing the columns?
Axis
collapsing.
2. Exactly.
Okay.
Yeah, Anmol, exactly right. So that's 0 plus 3, 3. 1 plus 4. Wait. No, this would be collapsing the rows. Okay. Or getting rid of the rows. Okay, so it means getting rid of the columns. Right. Yeah. Sorry. I keep thinking about this backwards.
Yeah. Collapsing columns means summing rows.
Rid of the columns. Yeah. So we get rid of the columns. 0 plus 1 plus 2. Now we've gotten rid of these columns. We collapse them down to one value, which is a 3. 3 plus 4 plus 5 collapses down to one value, which is a 12. All right. 6 plus 7 plus 8 collapse that down to one value, which is the 21. All right. This is giving me a migraine, but this is how you get rid of your columns. How would you get rid of your rows? How would you collapse down your rows? What axis would you use? Exactly. It's a 1. So getting rid of the rows, 0 plus 3. Let's collapse that down to 1 point, which is a 3. 1 plus 4, 5. 2 plus 5, 7. All right, and how do we know it's a 1? It's because if we look back at our diagram here, when we defined it originally, we did 3, 2, 3. 2 being axis 1, right, which is the number of rows. So 0, 1, 2. Stacks, rows, columns. Because we go from the outermost to the innermost. I now have a migraine. All right. Any questions on this? I'm so sorry for not understanding this at first, because this is it is very important to understand, but it's also very counterintuitive. 4 dimensions. Let's do 4 dimensions. Had a nice 4-dimensional array earlier, so I'm just going to copy that. There we go. So let's go back to our 4-dimensional array up here. And I guess, just to make life a little bit easier, let's come down here and do it like this. All right. R4 is equal to np.range. We'll do 5 by 5 by 5 by 5. 5 by 5 by 5 by 2. So we could do I'm bad at math, but we could do 2 times
if I suggest,
yeah.
do like a range 2 times 3 times 4 times 5.
Ooh, that's good.
And then now when you reshape, just say reshape 2.
Yeah.
So now all the sides are different.
Like that, right?
Mm-hmm.
Very nice. Okay, very good. That is very smart. Okay, so we now have a 4-dimensional array. Okay, so you all can see this, right? So the 3-dimensional array is this here, and we have 2 of these. So we have stacks of stacks, because each of these 3D arrays is a stack. So just like before, can anyone tell me if I wanted to sum along the columns, how would I do that? I'm going to give people a chance, whoever is still here, give a chance to answer this. Okay, so we're gonna try Anmol's answer, which I think is the correct answer. I'm not gonna pretend at this point that I'm an expert on this. All right, so this is what Anmol suggests. And that is correct, right? Because to sum along the columns means to take all the values in the columns, collapse them down to 1 point. So this is going to be equal to 10. This is going to be equal to 35. This is going to be equal to 60, and so on and so forth. So that's why you see 10, 35, 60, 85. If I wanted to collapse the rows, that would be this one here. Okay, so that would be the 2. So that would be the second axis. So now we take each of the rows, and then if we add 0 plus 5 plus 10 plus 15, that is 30. 30. 1 plus 6 plus 11 plus 16, that's 34, and so on. So hopefully this now makes sense. And don't worry if it doesn't, because you're going to get a lot of practice with this with Dan.
If you notice the shape of the output is going to be the shape of the original one, you just with that axis knocked out.
Yeah.
You know what I'm saying? So axis 2 is now missing. If you go, the original shape is 2 by 3 by 4 by 5, and this one's going to be 2 by 3 by 5.
So if we do like a print on r4.shape, and then we look at these, so we can see the original shape was 2, 3, 4, 5, and like Dan said, when we collapse that axis 2, which is this one, we just see it's the exact same thing but missing that axis. That was a much more intuitive way to explain this, Dan. Thank you.
Yeah, once you get into like hyperdimensions, the idea of like columns and rows and stacks like are meaningless, and I stopped giving them names, right?
Yeah.
It just starts saying like the first dimension, second dimension, stuff like that.
All right. So yeah, had enough of this one, I think, for today. Thank you all for sticking around for that. Okay, so I think, Jesse, you had mentioned you were having a little bit of technical difficulty. I was hoping we could actually include that in the recording, just because I think other people are going to find that same issue. Would that be all right?
Yeah.
Okay, great. So did you want to share your screen and show the error you were getting?
Sure, give me 1 second.
Sure.
Can you see it?
Yeah.
Okay. So when I execute the first command, I get the command not found, which I wasn't really sure about.
So any Mac people here? Oh, Mert said try pip3.
Yeah, maybe the alias is wrong. Maybe can you please try it with pip3 install numpy? The first line. Just want to make sure if you have. Yeah, just add 3. Just run that column, code block, please.
Ah,
Yep. Yep.
Okay.
So
there you go.
just add 3. Yeah. Now we are gonna add 3 pip3, all of them. Yeah.
Oh wait, is this using your Mac's version of pip? Because you're on a Mac, right? Doesn't that have a version of pip already?
Uh,
I don't think you want to do that, do you?
no. I think that pip3 refers to the Python 3 package she has. The pip refers to Python version 2.
So Anaconda should work out of the box. Like you shouldn't need to do any of this. There's something is wrong here. You know? You see, she's getting a permission denied error.
Oh, you're right.
Yeah, there's something wrong here.
Do you know where you installed Anaconda?
It's in my home directory.
Yeah, can you share your whole screen, Jesse, so we can see how you're opening up Jupyter? If that's okay.
Yeah. If it's Anaconda, you may not need to install.
Yeah, you wouldn't need to if you're using Anaconda. That's the thing that's weird about this.
So you could try by commenting them out.
Okay, I'm gonna try and share my whole screen.
But you should still be able to use pip. That's the thing that's weird about this. So how are you launching Jupyter Notebook? Can you show how you're launching it?
Yeah. So I just click on launch
Hmm.
and then it opens up. And then I just go to and then I would just click on this module.
It's really weird. Can you I want to see what library you were using. Can you put in the can you put this line in one of your code blocks? Which I don't know. Yeah, that's what I was about to ask. Yeah, so if you try running that, yeah. Oh, that's really bizarre. So I don't think you actually have initialized Conda yet. Maybe you should try Conda. Well, you don't even have Conda. Can you go back to your go back to your navigator? Can you try opening up the wait, where is the oh, this is really weird. Where is the Anaconda prompts? Okay. People who use Macs, how are you getting this? Dan, I guess is really a question for Dan.
Yeah, so I mean, I'll be honest, I don't use Anaconda. I just launch a virtual environment with Miniconda.
Yeah, well, this should work though. So if you go to your terminal, do you have yeah, can you open a new terminal? Yeah, you don't have Conda on there. This is weird.
No, I think she has, Henry, but she has to activate it.
Yeah, it's not been initialized yet.
Can you just do Conda activate base?
But she doesn't. Well, yeah, try typing Conda into your prompts and hitting enter. I mean, that should do something.
I don't think she has Conda.
Yeah.
She didn't include in her bash RC.
Oh, is that what you need to do on Mac?
Yeah, first she has to create that. So let me check.
Yeah, something during the install process, this was supposed to happen, but it clearly didn't for some reason. This is kind of bizarre. Okay. So what you could try is something to the effect of this. And I think your username is Jesse's MVP. This might be because you have like a dash in your name that might have tripped Anaconda up for some reason. I'm really not sure why that would be the case, but whatever. So whatever your username is, yeah.
Wait. That's not correct. It has to be like this. Home dash Jesse. But first, we don't know where the Anaconda installed, Henry. First, we have to figure that out.
Oh yeah, it should be. Well, okay. So yeah, see if you can figure out. So first of all, can you open up your Finder exactly?
Yeah.
See where Anaconda lives. Alrighty, it's an opt.
Okay. Yes. Good.
Oh.
Yeah. Then I think I have the code.
Yeah, I
give me
see
a
what you
minute.
did. Yeah, you did an admin install.
That's fine.
Yeah. Well,
It's here.
Is there a difference between the two types of install?
Yeah. So you've put it in your opt folder, which is kind of can be kind of confusing. Yeah. So it's exactly what. Wait, why is homebrew in there? Was it under homebrew?
Wait. I have homebrew in mine. In hers, can you open Finder again?
Yeah.
I have homebrew. That's the reason. It was opt.
It was just opt Anaconda 3. But
Yes, like
wait,
this.
if for some reason it's in your user folder though. See? So it's not actually the admin install.
But it's where the opt is. So can you please right click on Anaconda 3 folder and it will say info. Yeah, right click on it. Get info. Yep. That one. Awesome. Macintosh users Jesse opt. Okay. So it should be something like this. Home dash Jesse's. Yeah. It should be something. It should be exactly like that.
Well, I
Yeah,
think
you got the homebrew in there
oh,
again.
yeah.
Yeah, again. Oh my god, the previous one. Sorry.
Yeah, I don't think you want the variable for home there.
No, I think you will.
No.
Don't you think? Then it will be like this then. Users GCs like this. So, but we have to put this to bash RC.
Well, no, if you do conda init, it will do that automatically.
I a little bit disagree, Henry, because she has Anaconda. She has that conda. When she types it on terminal and it says conda command not found, it means that the terminal doesn't see that command.
Right. No, what I'm saying though is that if she puts it on her path and then runs conda init, it should add it to the bash RC automatically. Because like she does the export path, but then if you run conda init, it should automatically find your bash RC and add it to it after you put it on path. So you put it on path, run conda init, and then it should be in your bash RC without you having to actually find your bash RC and type it in.
By the way, it's not bash RC, it's ZHS. At the top, it says the default interactive shell is now ZHS.
Oh.
It's a Z
maybe that's got something to
shell.
do with, okay, maybe that's why this is happening.
Yeah.
Can you do before you try? Well, okay, so you can try that. I don't think it's gonna work though.
No. We have to put that command to ZHS first.
Can you just type, Jesse? Can you just type pwd? Okay, so never mind. That should have actually worked then. So try typing conda now. Okay, yeah. So try conda init.
Magic is happening.
No, init.
Oh, sorry.
Yeah, no problem.
The spaces or no spaces?
Yeah, with init, like init.
Okay.
No, 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 no
No, no.
space, no space. Just the word init. Yeah.
And the password is just what I use to unlock my Mac, right?
Yes.
Yeah, it's just your
Safe.
user password. You won't see anything as you're typing. It's a secure shell. Yeah. All right. Okay, so yeah, you see it changed her .bash profile. So try reopening this shell. Try closing it and opening a new terminal window. Because that's conda and it's supposed to automate that process. So yeah. Okay, there you go. So now it's right. I have no idea what happened. That's
Jesse,
really
just so
odd.
you know, the way we know it's right now is at the very beginning of your line, and now it says base in parentheses. That's how we know this is how Anaconda tells you what environment you're in, and the default one is called base. So that's how we knew that you're golden now.
So try completely stopping Jupyter Notebook and reopening it. It should now work correctly. But we just want to verify that this works. This is a very this was a very odd error. I've never seen this. Yeah.
So I can just hit launch again? Or do I have to close out the
No,
app?
no, do it from the terminal. Go to the terminal where
Yeah.
we just saw the base. Type Jupyter Notebook like this.
So for anyone who watches this later, the problem was that Conda wasn't on the path for Jesse. And the path is basically where your computer knows to find commands, right? So it wasn't sure where Conda was. And so stuff like pip wasn't working because pip is part of, well, this version of pip that you're supposed to use here is part of Conda. And it couldn't find Conda, so it couldn't find pip.
So just one tab to the left, you still have that notebook open. Just close that, just for, yeah.
Yeah. Yeah.
And then delete the 3s and try running it again.
It should be already installed.
Well,
I don't
yeah,
think she
yeah,
has
but
to-
you'll still be able to verify that this is working.
Sure.
Yeah, there you go.
Yeah, and now it says what it's supposed to. It says that you already have them, which is what's supposed to happen when you have Anaconda.
Okay, great.
Nice. All right. Thank you for the challenge. This was actually really cool.
Well, thank you guys for helping me out. I appreciate it.
Yeah, no problem. Do you have any questions about like what the issue was or like how the solution worked?
Not right now.
Okay.
I'm gonna stop sharing my screen now.
All right. Well, I think that was plenty for 1 week. Thank you all to everyone. Thanks to Mert and Simon for helping out with the with that solution. And yeah, see you all next time then.
Should we talk real quick about what we're doing next week?
Okay, sure. All right, I'm gonna stop the recording now. All right, see you all.